welcome back to Applied Mathematics. In this video, I want to talk about exponents and roots. This is where we're starting to get into, hopefully you've seen these before, but it's not necessarily expected anymore. So, a quick reminder that exponent notation involves having some base. I'll use an A to represent the base, and some exponent. I'm going to specifically look at an A to the n as my generic case. And A to the n means A multiplied by itself n times. This is very similar to the definition of multiplication. N times x is x added to itself n times. One of the really nice things that happens with multiplication and with addition is what we call the commutative property. 3 times 4 is 12, and 4 times 3 is 12, right? 4 plus 4 plus 4, or 3 plus 3 plus 3 plus 3. Either way, you get 12. That's the commutative property, and it's a really nice thing that we have with multiplication. With exponents, we don't quite have that anymore. Let's look at some relatively simple numbers. 3 squared, by definition, is 3 times 3, which comes out as 9. 2 to the third power is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So 3 to the second power, 2 to the third power are not the same value. You have to pay attention to which one is the base and which one is the exponent. But the basic idea is there. And just like addition and subtraction are inverses, multiplication and division are inverses, exponents are the inverse of another operation called roots. We're not going to have enough time this semester to get into how and why roots as an inverse of exponents work and how you can have exponents and roots meaning the same thing, but it does work. So the cube root of 8 is 2 because 2 cubed is 8. When we deal with roots, because they are very prevalent in geometry, it turns out that the square root is most commonly used. Right? So we're generally going to write it without an index at all, but technically speaking, there's an index of 2 there. We just are lazy and don't write it down. Either way, the square root of 25 is 5. And we can work through exponents and roots by hand. It's certainly something that can and will happen. But this is one of those places where making sure that we know how to use a calculator to do this is definitely valuable in and of itself. So, exponents on my calculator are done using the exponent key, which is pretty clearly marked. So if I want 3 raised to the 5th power, I can punch that in, I get 243. If I want the root, that's where things get a little bit weird. I'm going to type 5 first, then my second key, and you'll notice above the exponent key is this box with a radical symbol. That box is telling me that 5 is going to turn into an index. 243 is 3. Square root's much the same. because squares and square roots are so common, there's a shortcut key for that. 5 squared is 25. The square root of 25 is 5. Various calculators have very different ways of denoting exponents and roots. Some common keys that you will see are x to the y for an exponent, and also the caret key, kind of an up arrow looking thing. Here's an older calculator that I have laying around. Just throw it on top of the one that we're working with. You can see that the buttons are lined up mostly the same. I still have a squaring key. And then the notation just looks a little bit different. But if I want 3 caret 5, it still gives me 3 to the 5th power, which is 243. Square roots, as I mentioned in an earlier video, are often a cause of trouble because square roots very often, most of the time, do not work out nicely. Get that extra stuff out from behind my screen. Blue screens are lovely except when the blue of the display is getting confused for the blue of the screen. If I want to take the square root of a number that is not a perfect square, like say 24, some calculators will immediately give you a decimal value. Some calculators will try to be fancy about it. Again, for those of you who are moving onward, learning how this works is interesting, and being able to deal with simplifying square roots that have variables in them is a very interesting skill that we're not quite going to have enough time to worry about this semester. So for our purposes, we always want a decimal approximation. On my calculator, my decimal approximation key is right here. When I hit that, it tells me, oh, I didn't want to square root of 6. I wanted the decimal approximation, which is 4.898979, etc., etc., etc. So our calculators can do exponents and roots without too much issue. There are still some things that we should be able to do by hand. First thing that I want to mention, or the next thing I want to mention, is dealing with fractions. If I have 3/5 squared, I'll show you by writing this out in detail. 3/5 squared means 3/5 times 3/5, which is 3 times 3 in the numerator and 5 times 5 in the denominator. But, I can just do the calculation, but I want to point out here that 3 times 3 is just 3 squared, and 5 times 5 is just 5 squared. So if you learn this general rule, you can deal with squaring and cubing fractions without having to do too much work. That's particularly useful if you want to go the other way. If I want to take the square root of 9/25, following the same procedure we just talked about, well, that's probably the square root of 9 over the square root of 25. Square root of 9 is 3, square root of 25 is 5. If you know the first couple of perfect squares and maybe even perfect cubes, you can do these sorts of calculations pretty quickly. If you don't know the first couple of perfect squares, it's pretty easy to figure out. Use a calculator and just start squaring things. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and you can keep going until you get bored with it. You can do the same thing for cubes, or fourth powers or fifth powers, although those are much less useful. Right? Depending on your calculator, it might be able to do things nicely with these sorts of calculations, it might not. Once again, this calculator is pretty nice. So if I tell it I want the square root of a fraction that is 9 over 25, it can still do that for me. Although that's getting to the point of I can do that one faster in my head than I can punch it into the calculator. The last thing that I want to talk about here is how exponents and signed numbers get along with each other. So -3 squared. Well, -3 squared is -3 times -3. Negative times negative is positive. 3 times 3 is 9. And that seems simple enough. I guess I can plug that into my calculator. Remember, there's a negative key down here. You do not want to use the subtraction key. -3 squared. Wait a second. My calculator says it's -9. My arithmetic says it's +9. I unfortunately don't have my other calculator on hand, but there are in fact some calculators where when I punch this into my calculator, it gives me +9. This is one of those weird things that entirely too many textbooks try to teach you some rule or another for. And learning a rule is completely missing the point. The point is that this expression is ambiguous. And because it's ambiguous, it should never be written. I will never do that to you. I'm going to show you how these two schools of thought come into play, how it should be done, and why you might make a mistake with it anyway. So, if you want what I just did, what we're looking at is -3 in parentheses squared. This does give us -3 times -3, which does come out as +9. And if I jump back to my calculator and I include those parentheses, opening parenthesis, -3, close parenthesis, squared, it does give me +9. The way that my calculator interpreted this expression in the first place is a quirk of how computers handle negatives. The negative key doesn't quite do what we expect it to do. In fact, it's not a negative key, it's an opposite of key. Remember, back in the lesson on the signed numbers, the integers in the first place, I talked about the opposite of -3, which comes out at, the opposite of 3, which comes out at -3. Calculators handle the negative symbol using this opposite of interpretation. The problem with it is the way that they are programmed is that the opposite of 3 is -1 times 3. That's how this is programmed into the calculator. And if you remember the order of operations, which we will talk about in depth a little bit later, multiplication happens before exponents. So if I have the opposite of 3 squared, The calculator is going to interpret 3 squared first, and then take the opposite of that to get -9. If that's explicitly what you want, you might try punching that into a calculator as the opposite of parentheses 3 squared. I can't imagine where that might be useful, but I suppose that somewhere it is. So there's 2 things that you can use here. You can either simply remember whether the number is positive or negative to start with. When you square it, it comes out as positive. Then you don't have to bother typing the negative symbol into the calculator. Oh, -3 squared? Well, 3 squared is 9, and it's going to be positive, so it's just 9. I don't have to worry about typing that negative symbol. It saves me a lot of calculator strokes. That has its own problems that I'll get to in just a moment. The place where this becomes a point of confusion is if you have something like x squared, where x is -3. Now it is your job to substitute in, replace the x with -3. And it is your job to remember that when you substitute in, you have to include parentheses. Now you know how to punch it into your calculator and everything will work fine. -3 squared is +9. Just to make things a little bit more confusing, let's look at a different expression. -5 cubed. Now my exponent is 3. And you can see from my calculator that this comes out as a negative value. And if you double check by hand, that actually does make sense. -5 cubed is -5 times -5 times -5. -5 times -5 is +25. +25 times -5 is -125. If the exponent is odd, the result will stay negative. If the exponent is even, the result will always become positive. It's convoluted, it's confusing, it's just a rule, you can remember it. But it's just one more rule, and all these rules get jumbled up in a lot of people's heads. I know that entirely too well. If you want to rely on your calculator, you're welcome to. Just make sure that you know how your calculator works. I've been showing you this on my calculator where I have to put those parentheses in every time. Other calculators, you don't. I am, again, not going to trick you. If I scroll back up on my notes here, I am never going to give you this expression with the -3 squared without the parentheses and tell you to figure out what I'm supposed to mean and realize that I'm trying to do this tricky thing down here and get -9 out of it, not +9. That doesn't seem right. I'm not going to do it. But it doesn't mean you won't do it to yourself. So make sure you know how your calculator works. This is something you have to pay attention to and you have to be careful about. One last thing on this topic before I wrap up here. Kind of an interesting thing that showed up. Well, we established earlier, start writing the right thing, the square root of 25 is 5, because 5 squared is 25. But we also just learned that -5 squared is also 25. So why wouldn't the square root of 25 be -5? Well, that's a long and tedious answer. But it basically comes down to because we didn't like it. It's more convenient for most applications if square root of 25 is positive 5 and not negative 5, so that's what we went with. But because every problem invites another problem, we square positive 5, we get 25. We square negative 5, we get 25. What do we square then to get negative 25? My calculator says domain error. The reason it says this is that there is no such thing as the square root of negative 25. Or, I guess there is, but we're not going to get there in this course. The square root of negative 25 is not a real value. If you try to take the square root of a negative number, your calculator will panic. Generally, hitting the clear button gets it out of the panic. But I wanted to at least mention that that's a thing that can happen and explain why. Again, if you're continuing onward, you will talk about how to deal with that, why it can be useful to invent ways of dealing with that anyway. But those are beyond the scope of this course, so I'll wrap up with that. As always, thank you for joining me. If you have any questions, let me know. Otherwise, I'll see you in the next video.